we are going to be on our next set of notes, which is measurement and data. So go ahead and go to your blog page that's titled Measurement and Data, and get ready to start taking some notes. First, let's talk about data tables. You're all fairly familiar with data tables because we've used them a lot in many different labs. Data tables are used to organize and record the data that you collect throughout a lab. There's generally two main columns. One column represents the independent variable, one column represents the dependent variable. Recall from last unit that independent variable is the variable that we are deliberately changing. We're changing it on purpose. And the dependent variable is the one that's going to change in effect of us changing the independent variable. Now remember, if there's only one independent variable in an experiment, then that means it is in fact a controlled experiment. Unit of measurement should be included in the column headings for data tables. It does not have to actually be in each individual box, but can just be in the heading titles of the table to represent which measurement of unit is being used. Alright, let's talk about graphs. Now there's three main types of graphs. There's a whole lot more than just three types of graphs, but the three main ones are scatter plot, bar graph, and a circle graph. A circle graph can also be known as a pie chart. Scatter plots is used to show possible relationship between two sets of data. A bar graph is used to display and compare data in a number of separate categories. You're very familiar with the bar graph. We've used that for the mealworm unit, and we've also used it with the race car lab. Again, you have two bar graphs so far on your blog. And then finally, the circle graph or the pie chart is used when showing how each group of data relates to all of the data. For your notes, why don't you go ahead and go on Google Images and find an example of a scatter plot, a bar graph, and a circle graph so that you can put that into your notes so you have a visual representation of what each of those graph types look like. If you need to refer to my blog to see which images I use, you absolutely can. Alright, each graph is going to have a pattern. Now, step 5 of the scientific method is that data analysis step. A lot of times, scientists are going to use their graphs to analyze their data. They're going to look for patterns and trends on that data analysis step. Now, graphs can have two main different types of patterns. They can either be a linear graph or a nonlinear graph. A linear graph is going to show a relationship between the independent and dependent variable with a straight line. So it's going to be a straight lined graph. A nonlinear graph is going to show the relationship between the variables, but it's not going to be in a straight line. Again, go ahead and go on Google Images and find an example of a linear graph and find an example of a nonlinear graph to put into your notes so that you have a visual representation of what each of these graph patterns look like. Again, you can refer to my blog and see how they look. Alright, measurement. Let's talk about what measurement really is. Measurement is a description that includes a number and a unit. You should be fairly familiar with measurement so far. We use measurement in the mealworm unit and as well as with different labs we've done so far. We've mainly used centimeters, millimeters, and seconds for measuring time. What we're going to use from here on out for the purposes of our science class is the metric system. It is the most widely used system in the world. In fact, the only country that doesn't use the metric system is us, the USA. We are still on the English system. But for our purposes in science, we are going to learn the metric system because it is the most standardized system across the world. The metric system can also be known as the International System of Units, or SI. It is based on the number 10, which makes it very simple and easy to use. The metric system units, or the SI base units, are meter, Kelvin, gram, and liter. Meter is going to measure length, Kelvin is going to measure temperature, gram is going to measure mass, and liter is going to measure volume. Abbreviations. You have to make sure you're using the correct abbreviation or you're not representing the correct measurement. So for kilometers, if you want to abbreviate that, it's going to be lowercase km. Lowercase and capital letters do matter in abbreviations. So kilometers is km, or kilometers, however you want to say it. Milliliter is lowercase m, capital L for milliliter. Liter is a capital L. Meter is a lowercase m. Centimeters is a lowercase cm. And millimeters is a lowercase mm. Alright, conversions. Kilo stands for 1,000. So anytime something is kilo, liter, kilo, meter, it's going to mean 1,000 of that unit. Hecto is 100, always going to mean 100. So if it's hectometers, that means it's 100 hectometers. Deca is 10. 1 is the base. Now the base can either be meters, grams, or liters, depending on what you're using to measure or what you're measuring. Deci is going to be 0.1. centi is going to be 0.01, and milli is going to be 0.001. Keep this in mind because this is going to come into play in just a moment. So if you're a little bit confused, that's okay because it's going to be explained in the next slide. Now, how you decide how to convert different measurements in the metric system is very easy because it is all based on the number 10. So if you look at this is called the stair-step method. You are actually going to create the stair-step on either Canva or Google Draw, whichever you're most comfortable with. I used Google Draw, it's a little easier. And you're going to create the stair-step, and this is going to help you identify how to convert in and out of different units in the metric system. So kilo is obviously the highest unit, so it's going to go at the top of the stairs, which means 1,000. Hecto is 100, so it's the second step down, meaning 100. Deca is 10. Base is 1, which either can be meter, liter, or gram. Deci is 0.1. Centi is 0.01, and milli is 0.001. Go ahead and make this on Google Draw or Canva and import it into your notes where this slide is so that you have it for reference. We will talk more about how to convert in and out of the different units in the metric system as a class, and we will do lots of practice with conversions as well. All right, scientific notation. That's another important thing that you're going to use in science for the rest of your education. Scientific notation is a short way of representing very large numbers or very small numbers. The format for scientific notation is a times 10 to the b power. B in the equation is going to tell you how many places the decimal moved. If the decimal moved to the left, b is going to be positive. If the decimal moved to the right, b is going to be negative. So keep that in mind. Again, we're going to do a lot of practice with scientific notation as a class. So hang tight on that. Just know what scientific notation is and the format for now, and we'll talk about how to use it later on. All right, precision and accuracy. These are two vocabulary terms this unit that you probably have heard before but don't know exactly what they mean. Precision is going to be the exactness of a measure. You want to be precise when measuring. So if you just round to 30, that's not very precise. If you say 3.1 or 30.1, that's going to be a lot more precise. Accuracy is a description of how close a measurement is to the true value of the quantity being measured. So you want it to be exact and you want it to be very close to the value being measured. So accuracy and precision is huge in science because that's what makes your data the most accurate and precise. Models and simulations. A model shows the structure of an object, system, or concept. A simulation uses models to imitate the function, behavior, or process of whatever the model represents. So a model is going to show what the concept or system is. A simulation is going to show how it actually works or behaves or processes. The purpose of using models and simulations is to answer difficult questions, to represent complex systems, and to test new ideas, and finally to make predictions. Scientists use models and simulations all the time to help with their investigations. There are three main types of models: physical models, conceptual models, and mathematical models. Physical models represent the physical structure of an object or system, like a DNA molecule. That would be a physical model. There's scale models and there are life-size life-size models. A scale model is one that's not going to be the same size as the real thing. It's going to either be scaled down or blown up for the purposes of studying it. A life-size model is exactly like it sounds. It's going to be the same size as it is in real life. The advantages of using a physical model is that it's easier and safer to work with. The disadvantage of using a physical model is that it does have its limitations. It's not always going to function and work like the real thing would. Mathematical models use different forms of data to represent how a system or process works. This could very well be a graph. A lot of scientists use graph to represent for a mathematical model. Advantages of a mathematical model is that they can be powerful predictors. Disadvantages is that they can be oversimplified very easy. Again, you're going to go ahead and find a Google image for both a physical and a mathematical model and put those into your notes so you have a representation of what both of them look like. And finally, you have the conceptual model. The conceptual model is a representation of how parts of a system are related or organized. The advantages of a conceptual model is that it identifies patterns and similarities. It represents processes that cannot be directly observed. Disadvantages of using a conceptual model is that it can be oversimplified and misconceptions can come from it. A great example of a conceptual model is the rock cycle. How it is all drawn out, it shows the relationship between the 3 different types of rock: igneous, metamorphic, and sedimentary. And it shows how the process works from them to become different types of rocks. Again, though, it can be oversimplified or cause misconceptions from this conceptual model. Again, please go ahead and find a conceptual model example on Google Images and put that onto your blog so you have a visual representation of it as well. That's all for this unit, so once you've taken those notes, you're good to go. And don't forget to hit update on your blog. Thanks for listening.